channel. My name is Tobias, and today we're going to look at the connection between a derivative and the slope of a tangent line. So first up, we have to have this overview of derivatives. So on our left side we've got our functions, and on the right side we've got our first order derivatives. So if we've got a constant function, for example, then the first order derivative would be equal to 0. And that way we can see all the first order derivatives of our functions on the left side. So we have to use that for our examples down below. So let's have a look at the first example. So we first look at our function called f of x equals x squared, and we want to find out what this evaluates to when we find the first order derivative and put x equal 1 inside our expression. So first off, we have to look at our overview and see what x squared, what kind of first order derivative we've got there. So x squared, the first order derivative is 2 times x. So we go back and see that f prime of x equals 2 times x. That's from our overview, which is found in normal math textbooks. So now we want to evaluate this at x equals 1. So we just put 1 into x's places in our expression up here. So f prime of 1 is equal to 2 times 1 is equal to 2. So we can interpret this f prime of x equals 2 as the slope of our tangent where x equals 1. And to have a view of this in graphically, I've put this into my graph program called GeoGebra, and I've put in our function called x squared. So f of x equals x squared, and I've gone out to x equals 1 and up to our function, put in a point here, and in the program I can get a tangent to our function at this point. And if we look at this tangent line, it equals a linear function which says here g or y equals 2 times x minus 1. And this 2, that's our slope of the tangent, and we have calculated that up here using the first order derivative. So because of x equals 1, we put that inside, and we found or calculated the slope of this tangent using the first order derivative. So let's have a look at another example. So it's actually the same example, but this time we want to use it or evaluate it at x equals 2. So once again, our first order derivative of x squared is 2 times x. And now we put in x equals 2 on x's spots, and we evaluate this. So f prime of 2 equals 2 times 2 equals 4. So from our example up here, this should be the slope of our tangent where x equals 2. So let's have a look at our graph program once again. So it's the same function x squared we've got here, the graph of it, and I've gone out to x equals 2 this time, put a point on our graph, and used this program to get our tangent line on this graph, exactly at this point. And once again we've got a linear function, and the slope of this tangent is equal to 4. So that was what we calculated up here. So f prime of 2 equals 4, and that is exact the 4 down here. So we can calculate the slope of our tangent without using a program like this to calculate the slope of our tangents at specific values of x. So let's have a look at another function here. We've got e raised to the power of x. Let's have a look at how we find the first order derivative of that one. So that's a special function. So the first order derivative is just a copy paste of our function. So e raised to the power of x. The first order derivative is e raised to the power of x. So we use that in our expression, our example here. So we want to evaluate this at x equals 1. First off, we write out that f prime of x equals e raised to the power of x. We just saw that in our overview. And now we put in x equals 1 into our expression up here. And our computer calculates this and evaluates to the value 2.7182 and so on. So from our examples up above, we can now interpret this as the slope of our tangent line. And let's see that in our graph program once again. I've put in this function e raised to the power of x. Then I went out to x equals 1 on the x-axis and got up to our graph for the function, put in a point, and then I put in this tangent line, and the slope of this tangent equals this number exact, so 2.72. So if we round up here, that would be 2.72 also. So that's once again the slope of our tangent line. Instead of using a graph program and so on, we could just calculate it using the first order derivative. Then we've got the last example using the square root function. So we just have a look at how that one, what the first order derivative is of that one. So the square root of x, the first order derivative of that one would be 1 divided by 2 times the square root of x. So we just put that into our example here. We want this time to evaluate at x equal to 4. So the first order derivative is 1 divided by 2 times the square root of x. We just saw that in the overview. And now we put in, we have to say 4 here. So we put in 4 on x's places here, because we want to evaluate exactly this point. So 1 divided by 2 times the square root of 4, that equals 1 divided by 2 times 2, that equals 1/4, or 1.25, or 0.25, sorry. And if we use our graph program, we can once again see that we've put in our square root function into our graph program. We go out to x equal to 4, go up to our graph, put in a point, and then this program can put in a tangent line, and the slope of this tangent line exactly at x equals 4 is 1 or 0.25, and that is exactly what we calculated up here. So once again, we can use our first order derivatives to find the slope of our tangent lines to these graphs we are working with. So that's very neat for mathematics. Well, thanks for watching. See you next time. Bye bye.